Okay, so this is the problem I said I would give an example of how to solve. So you go through the information in the problem, and you put everything in its appropriate place in the data table. So when you go through 27 grams, that's your piece of iron, so here's your metal. So once your information is organized, the solving the problem is fairly simple. So you start with the understanding that the energy that's lost by the metal has to equal the energy that's gained by the water. The only thing, and the critical thing we need to just keep in mind that that will influence our answer here is when we lose energy, the temperature that it started at compared with the temperature that it ended at, when it's losing energy, here we're going to have a, since it's always T final minus T initial, and the temperature initial was greater, so I should write it over here, Ti, sorry, Ti is going to be greater than T final. When you subtract T final minus T initial, you're going to get a negative number. That's the key idea. So if you acknowledge you're going to get a negative delta T on what's lost, then we're going to just remember to multiply that by a negative 1. That will make that a positive number, which will also equal the positive number we're going to get for the energy that's gained. So that critical bit will be the difference between making your answer correct and incorrect. So now, you put your information in. Here's the mass of the metal, the specific heat of the metal. Now delta T, we said it's 46, that's what it ends up as, and we don't know what it started at. That's what we're going to try and solve for. So the product of this is going to equal the mass of the water times the specific heat of the water times the temperature change of the water. I've multiplied this 27 times 0.449 and I get 12.12 joules. And I haven't carried it through or distributed it. It's 46 minus Ti. That's going to equal 9,709 joules. So at this point what I'm going to do is I'm going to divide this by 12.12. Divide it by 12.12. When I do that, I'm going to get an answer of 801. Now notice joules cancel in this situation. So I had joules here. I'm being sloppy with my units. Joules here. So that cancels. I do have a, I'm sorry, what I should have is a, it's going to be 46 minus Ti. Now again, this is negative. Is going to equal 801. So if I just carry this through, I'm going to get negative 46 degrees Celsius plus Ti equals 801. This should have been degrees Celsius. So now when I add 46 to both sides, my answer is Ti is going to equal 847 degrees Celsius. So that's how that one is solved. Hopefully that helps. But I'll just make one other comment or repeat one comment, and that is, if this was not changed here to multiply by negative 1, then your answer would have been off by 46 plus 46. So you'd be off by 92 degrees. So just remember, when something is losing energy, the delta T is going to be negative, and so we multiply that by a negative 1.